So good evening and welcome to Maths with Sud. Today we are going to learn about irrational numbers. I am with my dearest student whose name is Akriti. Okay. So beta, we will start from the irrational number. So first of all, we have to understand what are irrational numbers, right? So I will say that there are two kinds of numbers in as far as we consider in the real numbers. Real numbers means the numbers which you can show on number line. Any number, so this is, suppose that this is a number line. Suppose that this is a number line. In between we have 0. On the right hand side we have positive numbers. What numbers? We have positive numbers. On the left side we have negative numbers. This is the basic thing that we know. Alright, we know that in the center of the number line we have 0, on the right side we have positive, on the left side we have negative number. Now if somebody asks you, how can you categorize the number? So these numbers are known as real numbers. Any number you point, take any point on the number line, that point will be a number. That point will be a number. You write any number on the board, I can show a corresponding point on that number line. You tell me a number, I will show that number on the number line. You tell me the point on the number line, I will tell you the value of that number. So both are possible. So such numbers which can be represented on the number line are known as real numbers. That is the definition of a real numbers. What are real numbers? Numbers which can be represented on number line. You can write down numbers. You have to be fast today, okay? Because we are having very less time. So I will cover most of the topic today, and because you are too smart to handle all these topics very easily, I will be a little faster, okay? So numbers which can be represented on number line, which can be represented on number line. Wherever you will not understand, please stop me, okay? Because I am smart, I don't know whether you are understanding or not. So it should be you who should stop me. Sir, please stop. I didn't get this. Please repeat this again. So I will repeat it for you. You are the only student.
So you don't have to worry about time and portions because we have a study holiday.
Yeah, that's a good thing. That's a good thing.
That's fine. You don't have to worry about portions.
Fine.
Because most of it has already been covered.
Okay, fine. So real numbers we will consider into two categories. How many categories? Two categories. The first category is irrational number. And the second category is rational number, which you are already aware about it. The second category is rational number. Now before going to irrational number, first we will understand the rational number, so that irrational you will understand in just one go. First we will consider on this rational part, okay? Now how many kinds of rational numbers are there? Do you have any idea? How many kinds of rational numbers are there?
No, sir.
Okay. So rational number is also categorized. Rational number is also categorized into two parts, dear. One is terminating decimal. We can write terminating decimal, or we can write, if it is not terminating, then it is repeating. Then it is repeating decimal. Alright. Now you might be thinking, sir, what is terminating decimal? What is repeating? I am not getting it. So let me explain you in a very easy way. Can you tell me what is 1 by 10?
What?
What is 1 by 10? It is 0.1. Okay. Can you tell me, beta, what is 2 by 100?
0.02.
Can you tell me what is 3 by 1000?
0.003.
Can you say that all these numbers, when I am writing in the decimal form of these numbers, they are terminating, means they are ending, they are coming to the stop at one point of time?
Yes, sir.
Okay. But if I ask you what is 1 by 3, you will say, sir, it is 0.33333, and sir, the board will finish off, but 3 will not come to an end. So I have to put 3 dots. Instead of that, I can write 0.3 bar. Bar means it is coming often, but often. The every next number is coming like this. Are you getting it?
Yes, sir.
If I ask you what is 1 by 6, you will say, sir, it is going to be 0. So if I divide this 10, 6 into 1, 6, then 46, 6 is 36, 1 point, so it is going like this, so it is 0.16 bar. So all these numbers are known as repeating decimals because the number keeps on repeating. Okay, we say these are repeating, they are terminating. Now, how can you differentiate between a terminating and a repeating just by looking at the number? You've been given a fraction. Suppose I give you a fraction. I will give you 2 by 5. I ask you whether it is repeating or terminating. Just by looking at the fraction, how can you verify? So it's a very simple trick, my dear. The numbers having the denominator 10, 100, 1000 or a multiple of 10 will always terminate. Are you in agreement with this? The number whose denominator, the fraction, the rational number whose denominator is a multiple of 10 will always terminate. Are you in agreement with this?
Yes, sir.
You see? And if the number is not having the denominator of the form of 10, then it will always repeat. If I ask you what about 2 by 7, it will be repeating. If I ask you what is 2 by 3, it will be repeating. If I ask you what is 15 by 7, it will be repeating. Because it is not having 10 in its lowest form. I also say that lowest form. Don't quote me, sir, 6 by 3, the denominator is 3, but it is repeating. It is terminating. No, you have to write the number in the lowest form. Lowest form means they should not have any other common factor. Suppose I ask you what is 7 by 21. So this is not the proper fraction that you should ask. You should ask, sir, 1 by 3. Because 7 by 21 is not the actual fraction. The actual fraction is 1 by 3. You have to ask the fraction in the lowest form. You will be given a fraction in the lowest form, and just by looking at the number, can you tell that whether it is a terminating or not? So the answer is, if the denominator is of the form of this, 10 to the power. So 10 means what? What are the numbers which are involved in making 10? Can you tell me?
2 can make 10, 5 can make 10.
Yes. So only 2 and 5.
Yeah.
Only 2 and 5. Okay. So if any number is having the denominator of the form 2 and 5, suppose I give you 133 divided by 2. Will it be terminating? The answer is, of course it will be terminating. Now you will be asking me, sir, you told me the denominator should be 10, but it is 2. So I will tell you, okay, denominator is 2. I can make it 10, my dear, because 2 into 5 is 10. So I can multiply both the denominator and the numerator by 5. So whatever the damn numerator will come, I just don't care about it. But I know that I have made 2 into 10. And 10 will automatically be a terminating decimal. We don't care about the result. We are just caring about the type of decimal. So if the denominator is of the form 2 or 5, then we say that the fraction or the rational number is always terminating. The rational number is always terminating. If it is not of that form, it is not terminating. All right. So we will write this as well. This is a very important quote, and you should write in your notebook. Let me quote it from a very nice book that I have with me. NCERT. And we will try to understand that part. Okay. So I want you to write this theorem as it is. And till the time you are writing it, I will explain you as well.
Yes.
So it is saying that let x be a rational number, any rational number, whose decimal expansion terminate. They are already saying that the decimal expansion always terminate. They are already saying that it terminates. Then x can be expressed in the form of p by q. That means it can be written in the form of P by Q when P and Q are co-prime. Co-prime means they don't have any other factor other than 1. And the prime factorization of Q, that means for the denominator, is of the form 2 to the power n into 5 to the power n, where n, m are non-negative integers, means they are positive integers. Okay, you can write this, means
Yeah.
they should be of the form 2 into 5 only. Apart from that, if any other number comes in between, they are never ever terminating, they will be repeating always. You understood this?
Yes, sir. Just 2 minutes.
Okay. Then I will ask you some questions based on this as well.
Wait, sir. Co-prime is?
Co-prime numbers are numbers which are having 1 as their highest common factor.
Okay.
For example, if I ask you 8 and 9, so do they share any common factor? The factors of
1.
8 are 1, 2, 4 and 8. The factors of 9 are 1, 3 and 9. Do they share any other factor other than 1 in common?
No.
No. So they are known as co-prime numbers. Co-prime numbers, two prime number are always co-prime. Two consecutive numbers are always co-prime. Please remember these 3 points. What are the 3 points? Two consecutive numbers are always co-prime. Consecutive means one after another. 8, 9, 2, 3, 5, 6. Two consecutive numbers will always be co-prime. Are always co-prime. Then you can write two consecutive odd numbers are always co-prime. Two consecutive odd numbers are always co-prime. And two prime numbers, two different prime numbers, not same, two different prime numbers are also always co-prime. Co-prime means the highest common factor should be 1. Are you getting
Yes.
it?
Yes, sir.
Co-prime means two numbers, HCF is 1. Two numbers whose HCF is 1, we say that they are co-prime number.
Yes.
Done?
Yeah.
Okay. So you understood one part, what is repeating decimal?
Yes, sir.
Now coming to the terminating decimal, let's come to the repeating decimal. So repeating also, okay, so for repeating also we will say like this. Please write down this definition as well. So
Okay.
they are saying that let x is equal to p by q be a rational number such that the prime factorization of q is not of the form, is not of this form, means they have any other number apart from 2 and 5 where mn are non-negative integers, then x has a decimal expansion which is non-terminating repeating, which is non-terminating. Non-terminating repeating means it is not terminating, so it keeps on repeating. That means like 1 by 3, 1 by 7, 2 by 7, 3 by 7, 4 by 7, 6 by 7, 8 by 9, 8 by 9, 9 by 11. They always repeat. They will always repeat. Done?
Yeah.
Okay. Now you understood two kind of rational numbers.
Yes, sir.
One is terminating and one is non-terminating, right?
Yes, sir.
Now the second question arrives, why a number repeats itself? Okay, so for that let me show you a very different, very fair logic. Suppose we are dividing 1 by 7. We are dividing 1 by 7. Please try to understand a very beautiful concept. So let us focus on the quotient and the corresponding, let us focus on the corresponding remainder and the quotient that comes. Okay, I will show you each case. So if a number is divided by 7, let us take any random number. Can you tell me, dear, what are the possible remainder that I can have? If any number is divisible by 7, not exactly divisible by 7, what are the possible range of denominators that I can get? Tell me.
Wait, sir, I didn't understand the question only.
Okay, so I am again explaining you the question. Suppose this is a number line, okay, and in the number line you are having different numbers, right?
Hmm.
You are having different numbers. I am telling
Yeah.
that I can choose any random number on this number line, and if I ask you what is the possible range of denominators if I divide these numbers by 7, what are the different remainders that I will get if I divide a number by 7? What is the different range of what are the different remainders? What are the different possible remainders? Possible remainders I can get if I divide a number by 7.
Actually, wait, sir, that's a good question because by looking at a number, how do you find out the different possible remainders you
You
can
choose
get?
any random number. See, there are some certain kind of numbers only. There can't be more than certain kind of number. If you are dividing a number by 7, there is a different range of numbers. You can't have let me say you, if you are dividing a number by 2, you can't have 10 as a remainder. Let me give you
Yeah.
an hint. If you are dividing a number by 2, you will never get 10 as a remainder. So there are a certain range of remainder as well. You cannot say that if I divide a number by 7, that particular number can also be the remainder. So I am asking you, what are the possible remainders that you can get if you choose any random number from this number line? Range of numbers, not one single number. I am not asking one single remainder. I am asking you the range of remainders. What are the possible remainders that you can get if you are dividing a number by 7?
So it's basically like a guessing game?
Yeah, you can guess. You can tell me what are the possible remainders. What are the possible remainders?
4?
Okay, very good. You can get 4. Wonderful.
Can you get 6?
You tell me, can you get 6 or not? You tell me.
Yeah, I think so.
Okay, so what is the number? So if you divide 6 by 7, you will get, of course, you will get 6.
Oh, okay. 3?
Yes, you may get 3. If you divide 3 by 7, you will get 3.
Oh, so in that case, then almost all numbers up till 7.
Up to 7. No, you can't get 7 as a remainder. Don't tell me that.
So below 7,
Yes.
any number.
Yes. Below 7, don't say any number. So you will say 1, 2, 3, 4, 5 and 6. These are the possible remainders that you will get if you are dividing a number by 7. Are you getting it?
Yes, sir.
But you will never get 0, because if you get 0, the number is an exact divisor of 7. The number will be exact divisor of 7. So the only possible remainders that you may get is from 1 to 6, which keeps on repeating. Are you getting it?
Yes, sir.
So suppose if you divide a number by 13, how many possible remainders you can expect?
So, like 12.
Very good. So 1 to 12, okay? Apart from 0, if you consider the whole of the remainders, you will say 13 remainders, that is from 0 to 12. But the repeating part will always be 12. Why? Because you can't repeat 0. Because if the remainder is 0, that means the number is exact divisor. Now see what happens, what I am saying now, I will show you here as a proof as well. What I was considering, you will understand a very beautiful concept of mathematics, which you are already aware of, but you have not noticed it. Okay, so suppose I am writing 7 into 0 is 0, so 1 is there, so I will put, so now you can say that what is the remainder? Remainder was 1, and with the corresponding remainder was 1, the quotient came out to be 1 because 7 into 1 is 7. Are you getting it?
Yes.
Okay. Now tell me what is the remainder?
3.
With corresponding remainder 3, what should be the quotient? So 7 into 4 is 28. Are you getting it?
Yeah.
So I am writing 4 here. That's a dirty 4.
This is a new way of division because I was not taught like this division
Okay, fine. So now you are getting it.
using. Yeah.
Okay, now tell me what is the remainder now? 2.
Yeah.
Again, if you put 0 here, what is the number that you will get here? 7 into 2 is 14. So that means you are getting 2 on this side. Now can you tell me what is the remainder now? 6. What is the remainder now? 6. With the remainder 6, again this will become 60 and 7 will go 8 times, that means 56. Again you will see that the new remainder is 4, and with the corresponding 6 remainder you had 8 as a quotient. Again this is 4, so what you will make is, this you will make it as 40, and 7 into 5 is 35. So you will say, sir, with corresponding 4 I am getting 5 as a quotient. Okay, again I am telling you, you have a pure look. With 1 as a remainder you are having 1 as a quotient 1. With 3 as a remainder, 4 as a quotient. With 2 as a remainder, 2 as a quotient. For 6 as a remainder, 8 as a quotient. For 4 as a remainder, 5 as a quotient. Now again you are getting 5 here. We will continue from here. 5 means you will again write 7 here. 7. So 7 into 7 is how much? 14. Again you will get 1. 1 means you already know what is 1. With 1 you already have 1 as a quotient. So that means this whole cycle will keep on repeating. You have to put a bar on this. That means if somebody asks you what is 1 by 7, you will say it is 0.14285 and again since 1 is there, so you will say it is a bar. Bar means it keeps on repeating. Now why it keeps on repeating? Because we have fixed this. This has been fixed. So what happens if this is fixed? So if 7 is fixed, the remainders are also fixed. The remainders, you will get the only set of remainders, you can't get apart from that. You will get 1, you will get 2, 3, 4, 5, 6.
Until 6 you can get.
Until 6 you can get. So what will happen until 6? After 6 you will again get a repeated form. So the maximum repeating decimals that you can get if you divide a number by 7 is 6. So that's why a number keeps on repeating. That's why we get a repeating decimals. Are you getting it?
Yes.
What is the reason we are getting a repeating decimal? The reason is that we are fixing the divisor. So what happens with the fixing divisor? The remainders are also fixed. If you fix a divisor, the remainder will be fixed, because this is what we have been taught in the division. You can't divide a number like this. Suppose there are some students, I find them, they write, okay, 10, okay, so we will write 3 into 2, 6, then I will write 4, then 3 into 1, 3. Oh, what is this? Can you write a remainder which is greater than the divisor?
No, you can't.
You can't, because then it will go one more time. It should have written 3 into 3 is 9. Did you get that?
Yes, sir.
So this is known as, it was a very beautiful, great mathematician of all time, you can say, Euclid. He gave this division lemma, that what I am teaching you is known as Euclid's division lemma. He taught us that if you are dividing a number by a certain number, if you fix this number and this number, you will always get a set of remainders which keeps on repeating. Because of that only we get a repeating part. Are you
Yes,
getting
sir.
it?
Yes, sir.
So this is the reason we get a repeating part. Now for terminating, I don't need to explain. You will always get a terminating decimal if you have a remainder as 10 or the power of 2 or 5. Because 2 and 5 can make 10. They are the
Yeah.
only numbers they can make 10. So with the help of that, if you have a denominator in the form of 2 or 5 or of this multiple of these two numbers, you will always get a terminating decimals. That means rational numbers are always of two kinds: terminating and repeating. Terminating and repeating. Understood?
Yes, sir.
Now then the next question will be, okay sir, then I have suppose 1 by 5 on the number line and 1 by 6 on the number line. Will I ever get a number which is non-terminating, non-repeating? Means neither it is terminating, or let us take a few examples. Let us see, if I ask you 1.37 bar, what do you think about this number? Is this a rational number or not?
Sir, it is a non-terminating rational number.
Okay, it is a, don't say non-terminating, just say repeating.
Repeat it.
It is a repeating. Why do you use non-terminating? Non-terminating has got two parts, repeating and non-repeating. So this
Yeah.
is repeating.
Okay, sir.
Okay, can you tell me, is this a rational number?
This is a rational number.
Then tell me what is the P and Q. Can you write this in the form of P by Q? Means I want a numerator and a denominator so that their value is equal to 1.37 bar. If you are so sure on this, you are telling me, sir, this is a rational number. So my next question is, then tell me beta, what are the numerators and the denominator I should write so that this number become a rational number. So here is the game. So you have to consider that number as x. What you will consider this number as?
X.
And then you have to multiply this number, this whole equation, by the 10 to the power that number. How many repeating decimals are there? How many repeating decimals are there? 2. So you will multiply this equation by 100. So you will have 100x is equal to 137.37 bar. You understood this part or not? Let me explain you here. So it is 1.37373737. It is going like this. Okay, I am multiplying this by 100. So what will happen? The decimal will jump 2 units to the right.
Yes.
Okay, so what it will become? It will become 137.37. Again the same part is repeating, so I will write 137.37 bar. Are you getting it?
Yeah.
Let this be equation number 2. Let this be equation number 1. I am subtracting 2 from 1. So I will get 99x here, and here 3737 will get cancelled out. So 137 minus 1 is 136. So the answer is 136 divided by 99. Let me show you as well in the calculator. Can you see the calculator?
Yeah.
See this, 136 divided by 99. See what is coming.
Whoa. Wait, but sir, I didn't understand how you got 99x. Why did you minus 1?
Because 100 minus x is how much? I subtracted the above equation from the below equation.
Oh my God.
I subtracted the above equation from the below equation. All right.
Yes, sir.
Let us take one more example. So suppose 2.23 bar. You tell me, by what number I should multiply this? Tell
Okay,
me.
so first we will multiply it by 100 again.
Wonderful. So we will write 100x is equal to 223.23 bar. Are you getting it?
Yes,
Let
sir.
this be equation 1, this be equation number 2. So I will do 2 minus 1. I am doing 2 minus 1. So 100x minus x is going to be 99x. And 223 minus 2 is going to be 221. This will get cancelled out. The decimal part will be cancelled out because they are equal. Are you getting
Yeah.
it?
So it'll be 221 by 99.
Very good. So let us check it out.
Yeah.
So 221 divided by 99. Just check it out. What is that?
Oh wow, that's so cool.
Cool?
Yeah.
Okay. Now I am giving you a number. I want the answer from you now. Okay? So tell me 3.54 bar.
So will it be 351 by 99?
Let me check, beta. So 351 by 99. 3.54545, correct?
Oh, nice.
Understood?
Yeah.
Wonderful. Good job. Now I will change it. I will twist a question. So the question that I am twisting it, I am putting a bar over just 4. Okay? I am putting a bar over 4. Now how to do this question? So again we will consider this number as x.
Yeah.
Okay. Now tell me by which number we should multiply this? Again?
Yeah.
10. Because this time only one number is repeating. So I will write 10x is equal to, so when this will be multiplied by 10, what you will get? 35.444, like this you will get. Are you getting it? 35 point, you can say 44 bar. Are you getting it?
Yeah.
Any doubt in this?
No.
Okay. Now again you subtract, so here you will get 9x. Here there is a different thing. So 35.44 minus, let us say bar, minus 3.54 bar. So bar will get cancelled with the bar part.
Yeah.
Now 14 minus 5 is how much? 9. And then this will become 4. So 34 minus 3 is how much? 31. So this will become 31.90, or you can say 31.90. Are you getting it?
Yes, sir.
So 31.9 will be what? It will be written as 319 by 10. And when this 9 will come down, this will become 319 by 90. Let us check it out.
Yeah.
See this? 3.544444.
Oh.
Are you getting it?
Yes, sir.
Please note down, then I will give you another question. You have to do it.
Okay, sir.
Very simple logic. How many numbers are repeating? That with that 10 to the power that number you have to multiply. That's it. That's it. And then you have to do a simple subtraction. But the subtraction has to be done carefully, because if you do a small mistake, you will arrive at the wrong answer.
Yeah.
Once you copy this down, I'm going to give you one more question.
Okay, sir.
Now the
So
bar is, yeah, tell me.
the bar only on 3?
3 and 4 I am saying.
Oh, okay.
It can't be that see, you can't write a number repeating here then ending it here. No.
Yeah, I was so confused. I was like, wait, what?
No. The
New
bar,
branch of
no,
mathematics.
okay, the bar is over 3, 4.
So would it be multiplied into 1,000 or
No,
no?
my dear, how many
100.
numbers? Yes.
Sorry, 100.
100. So what you will get, this is the important thing. What you will get, tell me.
1 second. 100x is
100x is equal to?
1 second.
If you are getting confused, you please expand this number properly. You please expand this number properly.
423 point.
423 point?
Just 423.34.
No. That's what. That's why I told you to expand the number properly and then tell me. You have expanded it to 4 decimal places or 6 decimal places. Multiply this by 100. Tell me what you will get.
So what?
I have expanded this number 234 here. 2343434 like this. I have expanded. I multiplied it by 100. Tell me what you will get. Decimal will move how many times to the whichever place when you are multiplying a number by 100? Decimal will move right side.
Yeah.
So what is the number that you will see? 423 point from what it should start?
0.4.
Yes. So 423.4 and again you will see a 3-4 bar going here.
Okay.
Again it will be 3-4 bar only. Now you have to subtract again. So on the left side you will get 99x.
X.
Can you tell me what you will get on the right side?
423.4.
Minus. You have to subtract this.
Oh, wait, we're minusing 4.
Yes, 4.234 bar, please. See, you can only cancel the bar part. Rest all you have to do it very carefully. The bar part you can cancel off.
So 419.
Point.
419.2.
Are you getting it? 4 minus 2 will be 2. So this will be equal to 419. Again you will put 2 and this 99 will come below, and because you have put the decimal here, so you will put a 0 below that. Are you getting it?
Yes, sir.
Let me show you. So 4192 divided by
990.
say this 4.23434343434.
Wow.
The bar is on 34.
This is cool.
Cool. Let me show you then one more question. Let me ask you. Now the bar is over 4-5. If you convert this by yourself, then we will move on to the next topic, or I will keep telling you, keep making you practicing on this. Okay?
Okay, sir.
Okay, yeah, tell me. You do by yourself. If you want to guide me, you can guide me. I, as a robotic person, I will write it for you. Whatever you will say, I will write it.
So it will be multiplied by 100.
Okay.
So 100x is equals to 1 second.
Be very careful in multiplying it by 100 or 1000 or whatever number you do.
This will be equal to 503.45 bar.
Don't say 4 or 5 bar. Say 4545 bar.
45.
The bar has to be said only after a certain decimal of digits.
Okay.
Are
So
you
now
getting it?
so it's 99x is equals to so it'll be equal to 498 point
So 45 minus 03 is how much?
what's it?
0.45 minus 0.03 is how much?
5 minus 0.03.
Yeah, you can see yourself.
498.42,
my dear. What is your confusion? I am not getting. Is there any
wait.
confusion?
The box confused me.
This box?
Yeah,
I'm sorry. Okay.
it's
Now,
okay.
now tell me. Now subtract and tell me how much you will get.
Yeah, I'll subtract.
I made the box so that you should not be getting confused by the 4-5 bar.
Oh,
Okay, the 4-5 bar will take care of 4-5 bar. That's why we multiplied it by 100 so that they can be taken care of by themselves. So the rest part apart from the repeating part, we have to subtract that part.
okay, sir. So then x is equals to 498.42 by 99, but then you remove the decimal place. So it's 1 second. 49842 by 99. How many? 00.
Okay, so let me show you 49842 divided by 9900. See this 5.0345454545.
Very nice.
Are you getting it?
Yeah.
Now I will tell you a very beautiful trick as well. The trick is the trick to find, no need to do all this. Okay, no need to do all this. You understood how we can get the number? Okay, let us find the trick. So the trick is suppose you have been given a number like this and you have been asked to write the number in the form of P by Q. Okay. So the first thing that you have to do is you have to check how many numbers are repeating. Tell me how many numbers are repeating? 2 numbers are repeating. So you will add 2 9 in the denominator. Are you getting it? Simple.
Yes, sir.
Now to reach to that decimal part which is repeating, how many jumps you will have to make from the initial decimal? Tell me how many jump you will make?
2.
2. So 2 jumps means 2 zeros. 2 jumps means 2 zeros. That is 100. You will multiply this by 100. Now this is your denominator. The numerator is write the whole number as it is. Write the full whole number as it is and subtract the non-repeating part. What is non-repeating part? It is 503. So 5 minus 3 is 2, 4 is 4, then you will get 498. See, you have got the same number.
Wow. So this works on everything?
Huh?
So this will work on any question?
Yeah, I am going to give you one question.
Yay.
So the question is, now the question will be a bit tougher. 398.65, 4 to 5 and the bar is on 4 to 5. Now tell me what will be the denominator first. How many numbers are repeating?
3.
So how many 9 we will write?
999.
3 nines.
And then 1.
How many zeros? How many zeros? How many jump you have to do to
2.
reach?
So 2 zeros.
2 zeros. Now this is the denominator. Now coming to the numerator, write the number as it is and subtract the non-repeating part. Write the number as it is and subtract the non-repeating part.
So you'll minus by 39865.
Yes. So 5 minus 5 is 0, 12 minus 6 is 6, then 13 minus 8 is 5, 14 minus 9 is 5, then this is 2, then 398. So this will become 398255560. Let us check it out.
That's
So
a very big number.
398255560 divided by 99900. See this 398.65425425425.
That's so cool.
So now I am going to give you one question and I will not help you out. You just tell me the answer. That's it.
Okay.
I am focused on the answer only. All right. You have understood the method, all the methods?
Yes.
Okay. So this is a number for you. You just tell me what should be the P, what should be the Q. That's it. It will hardly take 30 seconds if you do it in a sincere, proper manner. You take your time, no 30 seconds, take your time. Do it carefully, let me know. First, let's do accuracy, then we will do speed.
Okay, sir. So I got the answer. So 200. Wait, 2014527.
Wait. I have to write.
Yeah, big numbers.
20.
2014527
Yes. Okay.
over 9990.
Let us check it out. So 2014527 divided by 9990 and 2016543 Oh my God.
Yes. Pizza.
Wonderful. You cracked the game. Understood?
Yes, sir.
Good. Now coming to the irrational part.
Okay.
Okay, so do you know how to find the under root 2 of this? How to find the square root of 2? Do you have any no? Do you know how to find a square root of 2?
Square root of 2.
That
No.
means this value, this value.
Only if it's a perfect square, I know how to find.
Okay, if it is not a perfect square, you don't know how to find?
Yeah.
Okay,
Like
so
perfect square, you can kind of guess, but
okay, so if it is not a perfect square, then I will tell you how the part has to be found out. Okay,
yes, sir.
so this is a very long method. This method is known as long division method. This method is known as long division method. Now how to do? So first we will put a decimal part and write 000 and make the pair of zeros. Okay. Now dear, you have to think of a number in your mind whose square is less than 2. So the answer is 1. Are you getting it?
Yeah.
1 square is less than 2 square is 4. It is more than 4.
Yeah.
Now you have to subtract this. Again you have to bring down 2 more numbers. 100. You will put a decimal here. Now you have to double the number. You have to double the quotient. You have to always double the quotient. This you have to remember. Now you might be saying, sir, why it is so? So I will tell you, dear. So if you do x plus y whole square, what you do? X square plus 2xy. You always double the quotient. Are you getting it?
Yeah.
You multiply 2 times x. So that means you are doing double. Double of 1 is what? 2. Again you have to write a number here. So that the same number has to be written here whose value together with this is less than 100. So now say this. What is 1 into 1?
1.
1. Is it closer to 2? The answer is yes, but it is a far away from 2. Okay, now 24 into 4 is how much? 96. 900 minus 96 is how much? 4. Again I will bring down 2 more numbers. What I have got? 400.
400.
Again I will double the 14. I told you I will double the 14. So 14 will become 28 now. Again I have to put a number here so that the same number will be put here and whose multiplication with this will be a 3-digit number whose multiplication will be less than 400. So I know that this number is going to be 1 because 281 into 1 is 281 and 10 minus 1 is 9, 9 minus 8 is 1, 3 minus 2 is 1. Okay, so it is 119. Are you getting it?
Yeah.
See this now. Tell me what is 1.4 into 1.4? Sorry, 1.4 into 1.4. Can you see?
1.96.
Is it closer to 2?
Yeah.
It is closer to 2. How much closer? 0.04. The only distance left is 0.04. Now I am saying that 1.41 into 1.41 is how much? Tell me how much is this?
1.9881.
1.9881. Are you getting more closer to 2?
Yeah.
But will you ever reach to 2?
No.
You will always come like this 1.41, 4 again, then 2, something you will keep on getting a number, but you will be more closer to 2. Again you will have 1.9999, then 8888, but you will never reach to 2 ever. Now what is happening in this case of? Every time are you getting a different divisor?
Yeah.
So if you are getting a different divisor, the set of remainders which I told you will keeps on repeating. But will it ever repeat here?
No.
Because divisor is not fixed.
Yeah.
Every time the divisor keeps on changing. So if the divisor is changing, will these numbers will ever repeat? The answer is no. So such numbers are known as irrational numbers.
Oh.
Irrational means non-terminating. They will never ever terminate. And non-repeating. They will never ever repeat in their life. Why they will never repeat? Because they don't have a fixed divisor. They don't have a fixed divisor. See, so that means you can't write that number in the form of P by Q. Because this number okay, so what you can do is you cut down all the trees in the world, make all the land of your paper, draw out all the water from the sea, oceans, put them, make them ink of your pen, keep on writing all the numbers, you will never come to an end. The number will never come to an end. So that means they are non-terminating, non-repeating.
Yes.
So we will just write the approx value. Approx means we will write up to 2 decimals, 3 decimals, 4 decimals. Okay?
Yeah.
Okay, are you getting it?
Yes, sir.
So such numbers are known as irrational numbers, which I initially told you that they are non-terminating, non-repeating. Such numbers are known as non-repeating. They neither repeat and they neither terminate. Non-terminating,
non-repeating,
non-terminating, non-repeating. Two kinds of numbers. You can never write these numbers in the form of P by Q, P by Q, where P and Q are integers. You can write like this. Sir, I have written root 2 by 1 in the form of P by Q. Then what is root 2? Root
it's
2.
just there.
Yeah. So this is a foolish argument. Okay.
Yeah.
P and Q must be integers. Root 2 is not an integer. A number is a rational number if you can write it in the form of P by Q, where Q is not equal to 0 and P and Q belongs to Z. Z means integers.
Yes, sir.
The definition of a rational number is any number that you can write in the form of P by Q, where Q is not equal to 0 and P and Q belongs to Z.
Integer.
Z is an integer. And we have proved it here. Any number, you take any repeating part, see, this also you convert it into form of P by Q.
Yeah.
Any repeating part can be converted, but
but
if you keep on changing the divisor, if you keep on changing the divisor, the remainder,
it will not.
Yeah, so it will never come.
Yeah.
And this is the only process. And you can never get a perfect square of 2. You will get more closer to it.
But it will never be 2.
No, never. You will never reach it. You will always point. Suppose this is 2.
This 1.98.
So there are 2 kinds of numbers. We can say in the continuity. Suppose so this is a dot and this is a hole. So if you are reaching up to hole, that means you are not touching it.
Yeah.
And if it is a dot, that means you are in a continuous touch of that. So root 2 is this. You can never touch it. You can never touch root 2. Are you getting it?
Yes, sir.
You can never find a number which can multiply by itself to make it root 2. But you can write like this. You can write like this. Root 2 into root 2 is 2. But you don't have a value for this. You can write like this.
Because it's approximate.
No, means root 2, we don't know the value, but I can write in a short under root 2.
Yeah.
So if a number is a root, and again it is multiplying by itself, that means it will give you a square and a square root will get cancelled out. So you will get 2. But we can't find the value of root 2. Are you getting it?
Yes, sir.
Did you get this?
Yes, sir.
So this is all about irrational numbers. We will continue more. Please let me know if you want to have one more class. I have a free time on Wednesday. 8 to 9 is free I have kept it free for you. For this week or the next week, you can say, just because you are having exams. Okay?
Yes, sir.
So
I will check.
Please let me know if you want a class on Wednesday as well. If you don't want, it's okay.
Yeah, I'll check, sir.
Okay, we will meet on the next Saturday then. Okay? You enjoyed the class? Learned so many new things?
Yes, sir. This is very cool.
Okay, please remember this. Revise this.
Yes,
Okay?
sir. I
Chalo.
remember this.
Bye.
Bye, sir. Thank you, sir.
Bye, beta. Bye.